Thanks, everyone. My name is Abhiram. I'm a systems engineer at the Berkeley Lab. I work with the HPCS team. We manage a couple of clusters at the lab. We also do the same at the campus in UC Berkeley, so kind of a reputation of what we do. I might be able to dig a little deeper to the things that Julian just talked about, how we actually build stuff from a sysadmin build pipeline side of things. So brief intro is about HPC and our build process and what we do with Spack, or how we arrived at Spack, what we were doing before Spack, and our Spack workflow, issues, so on. So for those who don't know, there's a few HPC sites at the lab and in Berkeley. NERSC is the big one. It's a frontier class. And there's also Lawrencium, Savio. These are compute clusters that are available for researchers at the lab, and Savio is for researchers at Berkeley. And we also have a few specific ones that are for genomics or cryo-EM. So basically a scattering of HPC clusters, all with their own specific needs. Our group manages institutional HPC. We are distinct from NERSC. So just a quick overview of the clusters. They're reasonably big. All are Lustre, different microarchitectures, different GPUs, different CPUs, some variation in interconnects, but overall, they all kind of look similar. And similarly, there's Savio at Berkeley. And we serve a diverse pool of users, just like any other university, national lab. These issues bring in their own challenges. And a lot of these translate really well to other sites as well. We have a diverse set of scientific users. They have their own software stacks. And installing and maintaining these is complex, just the nature of things. And obviously, we are also trying to hit different architectures, different gen CPUs, GPUs, so on. So the complexities of this task are hard. So that's well known. So here are a few things we thought about, what we could do: automate things, use package managers, integrate with a good framework, testing framework. That way you can have a lot of confidence in your builds, what works, what doesn't. Obviously, there's trade-offs, and none of these are perfect, but these are the requirements that we have from our team. So, and Spack seems to fit most of these, so we went with Spack. So I'll quickly go over these. Basically, our main use case is users who are technical, who don't know what HPC is. So there's a very large spectrum of users. So we wanted it to be as transparent as possible. And we also have a couple of sites, so which means whatever we build in one site needs to be available in the other ones. So, and the other thing is we need multiple builds of the same package. We need modules, some form of version control manually, and also if nothing works in the automation pipeline, we also want to build things in a manual fashion, like good old times. So also, this is a huge deal, but to some reasonable extent solve the issue with Python. I'm not going to get into details of it, but these are kind of the large goals we had. And Spack fits a lot of these things really well. So we did a lot of testing in 2023. We created a test bed, shared these with all of our users, got a lot of feedback, and then eventually pushed things in June. So fingers crossed, 11 months now, things have been good. So what worked out really well were these. So Spack helped solve some of the problems. I'll talk about some that we had to figure out. So one was we now can have the same build pipeline in one cluster, replicate it to another cluster. And we also have 2 other sites that we are going to be doing this. Another kind of like nice feather in the hat is we also did reverse migration while Spack this was happening, so this is like a huge win for us. Whatever we did, we essentially rebuilt our stack, bunch of environments. Here is a new OS type. Everything went well. Obviously, there's going to be packages that didn't build, but that kind of comes with the territory. And our user-facing team is pretty happy. There are some edge cases, and I'm going to spend a lot of my time on those. Hopefully, these help other people who are in the same boat. So environments are really great. Obviously, when we started, we're kind of figuring things out, blind, reading the blind, I guess. So we put everything in a single environment, really bad. So don't do that. Essentially, split things up. Think about compilers. Think about languages like Python. So put them in different environments. It comes with its own edge cases, but for the most part, it gives you an easy way to manage things. And so that was a big thing. And Python, I'm going to dwell a little bit more on that, but there's no easy way to do things. But Python was a huge issue. And Spack views were great. And in fact, I think the new version of Spack, there's a new feature that's pretty cool. So we were able to at least hit a small portion of the problem. And our path is really good, but there are some edge cases. I'll also talk about that. This is a weird case for us. We have a build tree that gets synced over through, I can ask, I believe it's CERN VMFS. So there were some interesting issues, but our sysadmins figured out that bind mounts saved us. So, and the other thing is module sets. This is also really important for us, and there's a lot of customization that was baked into Spack, and we kind of learned things as we went along. Pretty happy about that, but also has a steep learning curve. So Spack environments are the ones that I'm going to talk about a little bit more. Essentially, take a big Spack YAML file, figure out what fits in where. GCC packages go to GCC, one API packages go to one API, Python goes to Python, and basically this kind of helped us a lot. Isolated builds, consistent rules, and so on. So essentially all the packages within an environment, they inherit some settings, and this gave us a lot of flexibility, build isolation, customization. So kind of like a big picture thing. So we split our environments into these. There was one big environment, and each of them have some definitions, modules, packages, so on. And we do some funky stuff with Python. I'll get into that. I don't think it's needed anymore, but this is something that we were doing on an older version of Spack. But the main thing is that environments really give us, bring a lot of benefits to the table. Concretization is faster, smaller error surface, easy to customize, and obviously Python views and modules, which are very essential for us. We were able to do some tricks with module sets, projections, so on. I guess to talk more about it, each environment writes to a specific install location, and we generate the modules from each environment. And these are either LMOD or TCL, and module sets for custom rules. And there's also the manual install portion, which goes in the same place. We have a huge team of students, staff who kind of address some of these. So this was pretty important for us. Python's funky. I'm going to talk about that. But this is kind of like the big picture of it. So obviously, the YAML stuff, we have, I don't know how to really showcase this, but I basically grabbed some chunks. So here is a module set. Here are some spec metrics from a YAML file, a bunch of different module sets. So we really make use of definitions and then hit them with use spec matrices, and then we're off to the races. So this is a specific environment that has a lot of packages in it. You have GCC, OpenMPI, so on. Obviously, Python the elephant in the room. We don't have a good solution to this, and if you know, please talk to me. But one thing that Spack offers is the ability to do views. So we kind of built on top of that. Essentially, this allowed us to do like a custom Python distribution for our users with a common set of side packages. I don't know how useful it is for everyone in our user group, but it solves some of it. And the other people, which I think are most of the people, they essentially bring their own conda or mini conda. So that's the nature of things. And for issues where Python is kind of known for blowing up our file system, especially when they're doing like large workflows, we kind of gently push them towards containers. And we have a few people who have a good amount of knowledge in this area, so we direct them to this, but no issue. This is a workaround that we did previously, where we were doing a Spack view that would do some funky symlink stuff, where each Python package that is installed by Spack gets symlinked, and for the user, they magically see everything in the side packages folder. This is no longer needed. I think this is version 21. I believe in version 22, Spack devs did something called a Python VENV. Essentially, this is what you would see. You may have 100 packages of Python. You don't have to module load all of them. You just do a view that gets symlinked into a side packages folder. So some problems, I guess for some users, they just want to load Python. They're like, I need NumPy, SciPy, what have you. And they can do that. So this is really good, but doesn't solve every use case, and we understand that. Another interesting issue was RPath that I talked about. Spack uses RPath. Essentially, this is a flag that's in the compiler wrappers. Works really well. You no longer need modules, actually. Modules are essentially just something you have to have because users are used to it. So, but doesn't work for every package. There are some edge cases. So what we ended up doing was kind of injecting LD path in these edge cases through projections. So essentially, these are a bunch of modules. The modules are YAML. It's like, OK, FFTW, the user wants this specific environment variable to be set, so I can inject it into that, and they're happy. So this was a huge issue for our user-facing team. They really did not want to do manual editing of modules, so a big win in my book. So that's one issue that we were able to work around, and thanks to the folks in the Slack channel who suggested this. And another thing we are testing, this is still kind of like in the works, is exposing our Spack tree to downstream users. We have a lot of reservations about it. Spack can blow things up, inodes, things like that. But we have, in Berkeley, we have a lot of advanced users who act as kind of like PI proxy software consultants. So we have more direct relationship with them. And we are doing this program where for really specific software that wouldn't make sense in our main tree, we are asking them to use Spack. We'll have a feedback loop for this for the next month or so, and then go from there. Really exciting, kind of reduces the work that our software consultants do. So it's a big win, but have to see how that works out. Testing is great. I don't know if there is any good ways to do it, but right now with Spack, as I mentioned, we did like a couple of OS upgrades. We use this thing called Reframe, where we have a couple of benchmarks and specific workflows that get triggered to specific time in the day. Just something that we decided to do, and this kind of made our jobs a lot easier. New MPI stack, does it work? Here is a bunch of tests, they work. So that kind of a thing. So for the future, we are pretty happy with our workflow. And obviously, massive thanks to the Spack community and all the devs. There are some issues when it comes to updating Spack. The new concretizer updates in 1.0 are going to change a couple of things for us. But based on a few people that I talked to, environment seems to be the answer. But I'm going to have to work on that. The other thing that unfortunately we couldn't kind of build on top of were build catching. We have some really specific vendor libraries that we use, and these are externals for us. So kind of kneecaps us. Maybe that's something that we can do in the future. That's pretty much it. The other feature that I'm excited about after talking to a couple of people here are nested environments. They basically have like a bigger environment that talks to smaller environments. So it's pretty cool. So that's that. This is a Spack team. Massive thanks to all of these people. This wouldn't be possible without their belief in us. A lot of them are user-facing. Wei is our team lead. And Sapna, Saroj, and Ellison were the user-facing people. So that's pretty much it.
All right, we got a question.
So you talked about you want to use, you want to investigate binary caches.
Yeah.
And you've got some site-specific constraints.
Yeah.
Are you planning or hoping to basically augment any build caches with a private build cache?
Yep. That's basically what we're thinking. Maybe if I can quickly go back to this environment slide. We have some replication going on here across these. So probably a private build cache could do it, but this is something that I have to explore. And from what I've seen, there are other people who are doing it. So if we can do this, then in another site that essentially has the same environment, we can kind of build on top of it. And that's the hope. I hope that makes sense.
No, that's excellent. I think that's an excellent direction.
Thanks.
Yeah, I'd be happy to talk with you about that. I have
Sure.
a few teams who
Sure.
do that right now.
Yeah.
Any other questions? Yes.
I had a question about the custom projections and how they're working out for you, because I really love the way that Spack, exposes and describes just all the build variants. And I hate the way that is lost in module files. And we do try to do like just suffixes and stuff like that to try to expose some of that nonsense.
Yeah.
But I mean, what's your experience with that? Do you have are there specific configurations that are really failing you with the projections?
So let's say HDF5, lots of variants, right? And we sometimes don't want to expose all of these variants in the module file. And I think that's more of like a call from a user-facing team. They're like, hey, they probably don't want to know which all of these variants that you have. Make that the default, and if there is an exception to that, add that in the module file, which is easy to do. In the projections, you could do a second, HDF5 that says, hey, I'm built with mpitch of this version. So you could do that. But I feel like it's more of like a user-facing thing than a Spack thing, if that makes sense.
Thanks.
Yeah, thanks.
I was going to say,
yeah, that would be nice.
That's a meta question for all our administrators.
Thanks,
Yep. That was going to be my suggestion, is when the users need specializations to the general versions, that's a prime opportunity for them to start using the environments directly as upstreams instead.
Yeah.
Because yes, stop using modules.
Yeah.
We just got modules in HPSF, by the way.
It's the way that people like to use them.
Did you hear me take more comments?
Thanks, folks.